हाय डियर स्टूडेंट्स, अगर आप इन वीडियो लेक्चर्स का मैक्सिमम यूटिलाइजेशन करना चाहते हो तो आई थिंक आपको ये इंप्रूव सेशन डेफिनेटली फॉलो करना चाहिए और रिलीजियसली फॉलो करना चाहिए। इंप्रूव सेशन क्या है, इसका लिंक डिस्क्रिप्शन बॉक्स में है, तो जाओ उसको चेक करो। इसके अलावा अगर आप व्हाट्सएप ग्रुप ज्वाइन करना चाहते हो, और मुझे लगता है आपको करना भी चाहिए, तो आप क्या करो, हमारे वेबसाइट पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो या फिर इस व्हाट्सएप नंबर पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो, सो दैट हम आपको उसमें ऐड कर सके। चलो अब पढ़ना शुरू करते हैं।
Hi, welcome back. And this is the assignment solution video for the Center of Mass and Collision. So let's get started. A machine gun fires a bullet of mass 40 gram with a velocity 12 meter per second. The man holding it can exert a maximum force of 144 on the gun. Okay, so how many bullets can you fire per second? So this is basically like you take the change momentum of one bullet, you multiply by n, and that is going to be the change momentum of all bullets per unit time, and that has to be the on an average the force exerted by the gun on those bullets, and in turn those bullets on an average they are going to exert the same force on the gun, and the gun has been kept at rest because of the force coming from the man. Okay, so the same force has to be applied on the man from the gun. Okay, so it's effectively the force that is like coming from the man and the force coming from the bullet on the gun that is balancing the gun. Okay, so suppose for one mass the change momentum is mv, initial momentum is 0, final momentum is mv, so this is change in mass of one bullet per unit time multiplied by n, and this n mv rate of change of momentum of all those bullets, n bullets per unit time, and that has to be the f external exerted, and that is your f. So you can solve for n is going to be and this is f by m into v. Okay, so you put the value of f is equal to 144 newton, m is equal to 0.04 because that this 40 is in grams, and v is equal to 12 meter per second, and you'll get n is equal to 3. Okay, so this is the answer, option number D. And let's move on to the next problem. A mass m moves with a velocity v and collides inelastically with another mass, identical mass, and after collision the first mass moves with a velocity v by 3 in a direction perpendicular to the initial direction of the motion. Find the speed of the second mass after collision. So here's a diagram, and this guy is initially at rest, this guy collides with this guy, and the first mass moves with a velocity v by 3 after the collision perpendicular direction of the initial motion. So in collision we know that momentum of the system in x has to be the momentum of the system in x in the final situation. Okay, so in x momentum is going to be conserved, in y momentum is going to be conserved. So similarly I can write pyi is equal to py f. Okay, so for this system let's write initial momentum is m into v, and since after collision this first guy is going in the vertical direction, there's no x component of its velocity, so let's assume the second mass is going something like this, so that is going to have some horizontal component vx and some vertical component vy. Okay, so from this calculation that they like these masses are identical, and the first guy is going in vertical direction with velocity v by root 3, and initially there is no y momentum, so this guy has to be moving with the same speed v by root 3 down the line, so that it's going to cancel the upward momentum of the first guy. Okay, and since initial momentum is mv, so this vx has to be again v. Okay, so because initial momentum mv and final horizontal momentum for the first guy is 0, so the second guy must carry the same momentum m into v. Okay, so for the second guy I can write its speed in x direction is v, and its speed in y direction is v by root 3, and the net speed if you want to calculate, that is going to be root over v square plus v by root 3 whole square, so that is going to be v square plus v square by 3, and this is going to give you 2 by root 3 into v. Okay, so this is option number D. And let's move on to the third problem. A bomb of mass 16 kg at rest explodes into two pieces of mass 4 kg and 12 kg. The velocity of the 12 kg mass is 4 meter per second. The kinetic energy of the other mass. Okay, so this is basically again conservation of momentum. The bomb was initially at rest, so p for the bomb was 0, and after the like explosion, the first guy is moving, this 12 kg mass moving with a speed of 12 meter per second, so 0 has to be 12 into 4, and say the second mass 4 kg mass is moving with the speed v. Okay, so this suppose the velocity v, so this 12 into 4 plus 4 plus 4 into v has to be 0, and that gives you v is equal to 12 meter per second. And since this is going to be negative, and that just shows key this is going to move in the opposite direction. Okay, and since here you can calculate the kinetic energy is going to be half into m, this, that is 4 into v square is going to be 144, and that is going to give you 288 joules. Okay, so this is option number B. Let's move on to the next set of problems. Okay, so the next question says a particle of mass m moving in the x direction with speed 2v is hit by another particle of mass 2m moving in the y direction with the speed v. If the collision is perfectly inelastic, the percentage loss in the kinetic energy during the collision is going to be. Okay, so let's draw the diagram. Moving in this mass m moving in x direction with the speed 2v, and is hit by another particle of mass 2m moving in the y direction with speed v. So here is another particle of mass 2m moving in the y direction with the speed v. Okay, so somewhere here suppose the collision happens. Okay, and if the collision is perfectly inelastic, the percentage loss in kinetic energy during the collision is going to be. So let's find first the velocity of the combined mass. Okay, so since the collision is perfectly inelastic, they are going to stick together. And let's talk about the x conservation and the y conservation. The momentum conservation in x direction is going to give you 2mv is equal to 2m plus m, that is 3m, and suppose vx. Okay, so that vx is going to be 2 by 3 v. So the combined mass is going to move in the x direction with a speed of 2 by 3. And again, so this was the px conservation. Similarly, the py conservation is going to give me 2mv, this 2mv, and again 3m into vy, and that again vy is going to be 2m by 2 by 3 v. Okay, so the particle is going to have the same velocity in x and y, and the combined mass is going to move something like this. Okay, now they want to find the percentage loss in the kinetic energy during the collision. So let's find the k initial of the system, that is half into m into 4v square plus half into 2m into v square, and that gives me this is 2mv square plus mv square, that is 3m v square. Let's cross check the calculation again. This is 2 cancel out 2, so this is 2mv square, and this 2 cancel out this 2, so mv square. So total kinetic energy before the collision is 3mv square. The final speed, you can say final speed is root over vx square plus vy square, and that is going to be 4 by 9 v square plus 4 by 9 v square. And again that is going to be like you can take v square common, and that is going to be 8 by 9. Okay, and 8 by 9 is just you can write root over 8 by 3 v. Okay, so this is the final speed of the combined system. Okay, now let's calculate the final kinetic energy. So KEF is going to be half into the combined system mass, that is 2m plus m, that is half into m total mass into v square, that is going to give you 8 by 9 v square. Okay, so this calculates to mv square 4mv square by 3. Okay, so this is the final kinetic energy of the system. So loss is KEI minus KEF, and that is going to be 3 minus 4 by 3 mv square, and they want the percentage loss in the kinetic energy during the collision. So percentage loss will be loss divided by KI. Okay, so KI is 3 mv square, so this cancels out, and if I'm going to solve it, I'll get 1 minus 4 by 9. Okay, and 1 minus 4 by 9 is 9 minus 4 by 9, that is 5 by 9, and 5 by 9 is and this is close to around 56 56%. Okay, so this percentage loss in kinetic energy during the collision is going to be a 56%. Okay, so let's move on to the next problem. Okay, so the next problem is from JEE Advanced. Okay, and this is 2001 screening. So two particles of mass m1 and m2 in projectile motion have velocity v1 and v2 respectively at time t is equal to 0. Okay, and they collide at t naught. The velocities become v1 dash and v2 dash at time 2 t naught while still moving in the air. Okay, so the value of this whole expression, so m1 v1 dash plus m2 v2 dash minus m1 v1 plus m2 v2 is going to be, okay, so if you think about this equation for a time being, this is basically the numerator in the calculation of the center of mass's velocity. Okay, so this is the center of mass's velocity, just divide of that m1 plus m2 term, and this is also the center of mass's velocity. So this is some sort of the initial center of mass velocity, and this is the final. So if we are going to use this formula that v com is equal to u com, v is equal to u plus a com into t. So center of mass has some acceleration a. It initially started with some initial velocity u, and then we have some velocity v. So v com after the collision, that is going to be m1 v1 dash plus m2 v2 dash divided by m1 plus m2. Let's calculate u com, initial velocity center of mass, that is m1 v1 plus m2 v2 divided by m1 plus m2. All these are the vector forms. Okay, so this is vector, this is vector, and this is also vector. Okay, let's calculate a com. A com is m1 and the acceleration of the first guy, and that is g downward, plus m2 acceleration of the second guy, that is g downward, divided by m1 plus m2, and that just gives you g. Okay, so just put these guys in equation form. So v com is equal to u com plus a com. So you're going to write this whole thing is equal to this whole thing plus g into t, and in t, since this is the velocity after time 2t naught, you're just going to write m1 v1 dash plus m2 v2 dash, okay, and divide by m1 plus m2, that is v is equal to m1 v1 plus m2 v2 divided by m1 plus m2, that is u. So v is equal to u, and I'm talking about com, v is equal to u plus a into t, and that t is 2t naught. Okay, so just multiply both sides with m1 plus m2 and take this term to the left, and you have the exactly same equation, and that's going to give you 2gt naught m1 plus m2. Okay, so this is answer D. Let's move on to the next problem. Two blocks of masses 10 kg and 4 kg are connected by a spring of negligible mass and placed on a frictionless horizontal surface. An impulse gives a velocity of 14 meters per second to the heavier block in the direction of the lighter block. The velocity of the center of mass is. So you have one spring, you have the other spring, and this is 10 kg, this is 4 kg, and the surface is frictionless, and an impulse gives a velocity of 40 meters per second to the heavier block. So this heavier block has been given a speed of 40 meters per second towards this 4 kg, and they're asking about the velocity of the center of mass. So we just have to use the formula of v com, and that is m1 v1 plus m2 v2 divided by m1 plus m2. Since at t is equal to 0, this guy doesn't have any velocity, and this guy is having a velocity of 40 meters per second. So just multiply 10 into 14 plus 0 divided by 14 cancel out, and that gives me 10 meters per second. So this is the velocity of the center of mass. Okay, so let's move on to the next problem. Okay, so the next question says a particle of mass m is projected from the ground with an initial speed u naught at an angle of alpha with the horizontal. At the highest point of its trajectory, it makes a complete inelastic collision with another identical particle which was thrown vertically upward from the ground with the same initial speed u naught. Okay, so the angle that the composite system makes with the horizontal immediately after the collision. So I'll try to explain it in form of diagram. So it's given that there is one particle, it's thrown with a speed u naught at an angle of alpha, and at the highest point of its trajectory. So the trajectory is going to be something like this. okay, and at the highest point it's moving horizontally, and it makes a completely inelastic collision with another particle which was thrown vertically upwards from the ground. So at this point the collision is happening, that means the other guy was thrown just below it, and this was thrown at a speed of u0. Okay, so at this point, if collision is happening, again you can say, like, even if the collision is inelastic collision, you can say the momentum of the system will remain constant. Okay, so the system, if I'm talking about the particles at like just before the collision, this guy is the first guy, and the second guy, the first guy is moving with a speed of u0 cos alpha. Okay, and you have to figure out what is the speed of the, or the velocity of the second guy just before the collision, and you should be able to see that this guy is going to travel the maximum height achieved by the first projectile, and the maximum height formula you can say is h max is equal to u square sine square alpha divided by 2g. Okay, so this is the maximum height, or this h max, okay, attained by the first particle. So just use the equation of motion for the second particle. You can use v square for the second particle is equal to u square, that is u0 square minus 2 into a, and as the distance traveled in the vertical direction is u square sine square alpha divided by 2g. Okay, so this cancel out, and this v square is equal to u0 square 1 minus sine square alpha, or that gives me v is equal to u0 cos alpha. Okay, so the velocity of the second guy just before the collision is again u0 cos alpha. Now you have two masses, okay, and it's given the particles are identical. So this mass is having this u0 cos alpha speed, and the other mass is having the u0 cos alpha speed, and this one is I and this one is J, and this is the system's initial total momentum. Okay, so just after collision, this has to remain constant. Okay, so just after collision again it's going to be the same momentum, and the net momentum of the system is going to be like this, because you are just adding two vectors equal in magnitude, and that equal vector is going to make an angle of 45 degree with the horizontal, and that is basically the question. Okay, so the angle that the composite system makes with the horizontal immediately after collision is just going to be this 45 degree from the x-axis, and that answer is pi by 4. Just think about, you're just basically adding two vectors equal in magnitude, one is in I and one is in J. The resultant has to make an angle of pi by 4 with any of these axes. Okay, let's move on to the third problem. Two blocks A and B, each of mass m, are connected by a massless spring of natural length L and a spring constant K. The blocks are initially resting on a smooth horizontal floor with the spring at its natural length. Okay, so this guy is moving, and this A and B initially they are at rest, and this spring is in its natural length, and this C is moving with the velocity of v. A third identical block, and this is the third block they're talking about, moves on the floor with a speed v along the line joining A and B, collides elastically with A. And then you have to find the kinetic energy of the AB system and the maximum compression energy of the spring. Okay, so let's start. So here I'll redraw the system. Okay, so this is my initial C mass moving with velocity v, and here is my A, and somewhere here is my B. Okay, and the natural length is L and A. This moving with C. Okay, so the third identical block C of mass m moves onto the floor with the speed v along the line joining A and B, and collides elastically with A. So if this guy is going to collide elastically with A, again from the conservation of momentum equation, we can see that this guy will stop and this guy will start moving with the velocity of v. Okay, so after the collision, this guy starts moving with velocity v, and this C guy stops. Okay, so at t is equal to 0, the kinetic energy of the system is half into m into v square. Okay, and there is no dissipating, like there are no dissipating forces, and whatever forces are going to be exerted on each block is going to be the spring force, and that happens to be conservative in nature, so you can also apply the conservation of mechanical energy for this system. Okay, so the kinetic energy of AB system and plus the potential in this AB system plus this spring is going to be constant. Okay, so let's talk about the K of the system at maximum compression of the spring. Now if you think about at t is equal to 0, there is a velocity of center of mass. So velocity of center of mass is m into v for this guy and plus m into 0 for the other guy divided by m plus m, and that is going to be v by 2. Okay, so the initial velocity of center of mass is v by 2, and at any time there is no net force on the system, external force on the system, so this v com is never going to change. Okay, so the kinetic energy of the system, center of mass velocity of the system is always going to be v by 2. So even I'm talking about the maximum compression, you cannot have kinetic energy of the system 0, because saying kinetic energy is 0, saying k is equal to 0, that means you are saying individual velocities or individual speeds are also 0, and that's not possible because the momentum of the center of mass is never 0. So there has to be some non-zero velocities for A as well as B such that the total velocity or the center of mass is v by 2. So this A is not correct. Let's talk about the K of the system at the maximum compression. So if I'm talking about the maximum compression, obviously this A and B, they will be moving together with the same velocity. So using conservation of momentum, I can write mv is equal to 2m and v dash, where v dash is the common velocity and v dash here comes out to be v by 2. Okay, so at the maximum compression they will be moving with this common speed of v by 2, and if I'm talking about the maximum compression, so there will be no loss in kinetic energy, or there will be no loss in total energy. So total energy initial has to be equal to total energy final. So TEI is equal to TEF, and TEI is just comprised of the KE, so half m v square, and TEF is half into 2m into this v dash square, that is v square by 4, plus potential in the spring, that is half into k into x square. So this is the x is the maximum compression. If you're going to solve it, this is going to half mv square and this will be mv square by 4, and half mv square minus mv square by 4 is mv square by 4 is equal to half k x square, and that gives me x is equal to mv square by 2k, and this is going to be in root over system. Okay, so this is the maximum compression of the spring. Okay, mv square by 4. So this is the option number D, right? So this D is correct, and they're also talking about the kinetic energy of the AB system at the maximum compression. At the maximum compression, you should be able to see that this is the system is moving with V dash, and this is the kinetic energy of the system at the maximum compression, that is half into total mass into the common speed, that is V dash square is equal to V square by 4, and that translates to mv square by 4. So this is the K of the system at the maximum compression, and this is the maximum compression itself, and that is nothing but m by 2k root over into v. Okay, so the answer is B and D. Okay, so I know this was a little bit quick, but this requires a prior understanding of the conservation of energy and conservation of momentum. So I hope this this was helpful, and I'll see you in the next video where we'll talk about rotation and all. Okay, thank you.